All right, Jam. Winter is upon us. Not really. I want it to be, though.
Yeah, I was about
it's
to say,
coming.
like, I was like, wait, how far ahead are we recording? Because I don't think it's here. I don't think it will be here.
Well, I'll say that as winter approaches, that's why, I did moisturizer episode.
Oh, yeah.
I just want us to get ready for, what is that meme that's like, winter is coming?
Yeah,
You know?
yeah.
I just want us to get ready for winter coming.
Okay.
And a thing that always happens to me in winter when I wear, especially these boots that I'm wearing right now, is that at work, when I go to touch my microwave, if I'm wearing these shoes or other ones with similar soles, I get shocked every time I touch my microwave or my little dry erase board.
Interesting.
A little static shock.
Okay. Right. Static. Yep.
Static. Yep.
Yep.
So I get a little shock and it doesn't feel great. And so then I'm like, what even is that?
Yeah.
Why do we get that?
Okay. Interesting.
And so I'm wondering, what do you know about static shock? What do you think about static shock?
Huh. I don't know if I've thought that much about it. I have a couple stories I could share once we get into it of times I've experienced it like that. But yeah, I don't know if I have a theory. I mean, we talked about electricity a little bit and just the like electrons of it and then trying to like go from one place to another, you know?
Yeah.
Or there's like too many in one place and as soon as they can, they want to go somewhere else.
Yeah. Well, let's talk about it.
Okay, deal.
Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast that helps you understand the chemistry of your everyday life.
And today we're talking about static shock.
Before we talk about that, can I ask you, what? Melissa, what are you wearing? Who are you wearing?
Oh, I'm wearing Chemistry for Your Life, T Public.
Nice.
You know what's crazy is I feel like when I was at the designer's store, I saw that exact same shirt.
Oh, yeah, when you're at Gucci or something like that. Yeah.
Yes, I am wearing my brand new Yay Chemistry t-shirt.
And this design is not new, but we just did a refresh of our own, our own merch items that we own. Mm-hmm. And so check out this Yay Chemistry. This is a new, the material, the type of shirt it's on is a new thing. It's a vintage tee that they have over on our store. It feels great.
I like the softness of it. Without it being like, sometimes soft shirts like cling a little too much, but it's not clingy.
Yes. And then mine's also one of the vintage ones. This is our, this is one of our newest designs that we came out with in like this past May. It's a new Intermolecular Forces t-shirt. Check it out. Also on the vintage
cute.
black. And these things are available at chemforyourlife.com/store, and they help support the show. Mm-hmm. And check it out.
Check it out.
Oh, and my hat, the ghost hat.
Oh, yeah.
I was
cute.
I was too jealous of the one that I got for Melissa, so I had to get one.
Yeah, it's really cute.
So if you want a little ghosty, there's a lot of other ghosty stuff. That's not what we're wearing mostly here, but this is the ghost we've been talking about. Mm-hmm. So check it out.
All right. So yeah, check it out, and then you'll get to tell your friends, oh, see this shirt? It taught me about static electricity.
Nice.
You know, so now we're back into it.
Nice.
That's
Perfect.
my transition.
Perfect.
Okay, so what is static electricity? And so I'm going to give you the basic pat sort of answer, and then I'm going to tell you why that doesn't really tell us all we know.
Okay.
Okay, so static electricity is essentially when two materials come into contact with one another, they can exchange electrons. This is called contact electrification or triboelectrification.
Okay.
And so these two materials can exchange charge, and then a lot of times when we feel the shock, it's the charge dispersing. So like if a charge has built up between us, a differential in charge between us and something else, when we get close enough, the electrons can move through it. We think electrons, just like a little lightning strike.
Okay,
it's
right.
Just mini little lightning bolt from your fingers to out and about.
Okay.
And have you ever seen this when it's dark? Have you ever seen static in the dark?
Yeah, you actually see a little flash.
Yeah.
It's so weird.
It is so weird. It's a little lightning.
It reminds me of like when we did the what were those the lifesavers crunching them
Yep.
or whatever in the dark. It's just like that little very brief little flash. Yeah, very weird.
Very weird. And I'll say that I've seen in the dark, like we have like camping blankets, and I like pulled one off of me, and it was like, and you could like feel it and see it, and it was very cool.
The place we experienced static electricity the most with us and the kids is at one of the parks near us at the school has AstroTurf.
Yep.
Very, 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 very staticky.
Interesting.
Then the slides also are staticky. That's everywhere.
Yeah.
So it ends up being just like a much more staticky experience. The slides.
Yeah.
The AstroTurf.
Yeah.
And there's times we'll go down and like the kids' hair, depending on how like sweaty they've gotten yet or whatever, will just be like, up if their hair's not sweaty.
That's cute.
And it's just very funny.
Well, now when you see that, you can think about this episode. So
Okay.
that's fun. So yeah, it does seem just like a fun phenomenon where you're like, oh, my socks are sticking to my sweater in the dryer, or like, hey, my kid's hair standing up. That's cute and funny. But it actually can have a lot bigger of an impact in everyday life experiences. So static is part of, or contact charge is part of what's happening when bees get like pollen on their body. That's why pollen clings to the bee's body. So that helps with pollination happen. And there was an article that, a peer-reviewed journal article that gave the theory that early on in Earth, there was a lot of these small dust particles from like volcanic explosions before there was life on Earth. And so these particles would interact with each other, like collide with one another and build up some of that contact charge and create lightning, which then would be enough energy for reactions to happen. So that could have been some of the energy needed for those first few chemical reactions to happen that ultimately culminated in life. So that's a theory. But also they can cause, they can trigger chemical reactions they can basically cause fires in like, with fine particle situations like in grains and silos and things like that.
Yeah, I have heard of that. That's crazy.
One thing said they cause 1 to 2 major industrial fires a day. And I was like, around the whole world, or just like, that seems like a lot.
Yeah, for real.
1 to 2 major industrial fires a day. So static shock has a big role, and it is beneficial for us to know, like, okay, why do we even care about this?
Yeah.
And then some chemists are trying to harness it as an energy source. So they're using, I didn't write down the acronym, but they're using this triboelectric. They're like making a machine that like pulls tape apart and then tries to harness that energy. So basically add it to solar energy, to hydro energy.
Yeah.
Tribo energy. We're going to get that too.
Interesting. I thought of one more area that comes up in my life on a daily basis.
Okay. What is it?
Coffee. When you grind coffee,
yes,
it becomes little particles. They want to cling to the inside of the grinder, that cling to the inside of the little like grounds catcher. And so for that reason and a couple other benefits, many of us coffee nerds, we do a light misting spray of our beans before we grind them.
Yeah.
And it is a game changer.
Yeah.
So there's going to be many areas where I think about this episode.
Yeah. That's kind of fun. I'll think about it now when I look at Mason's coffee grounds that do that same thing. They stick to the inside like that, like you mentioned. Okay, so those are some everyday life areas and some of why we care. But this buildup of charge or static electricity is called the triboelectric effect or contact charge. And like I mentioned, it's just charge transfer happening on contact. The problem is we don't know how or why this charge transfer happens. We can't even say for sure that it's electrons moving. Like we don't know the mechanism of what's moving the charge around. And so there's been lots of experiments studying this. There's an experimentally derived ranking of materials, and it's called the triboelectric series. That's saying like, okay, these materials are more or less likely to gain or lose charge. But those are experimentally determined. So they're not really based in theory. And one researcher did this like super carefully controlled experiment where he had two separate versions of the same material, and he would bring them together with like a contraption that controlled the amount of force and like everything. So they were both should have been experiencing the exact same environment, and then the two same material come apart oppositely charged.
Huh.
So there's just a lot of questions that, okay, how or why is this happening this way? We don't really know. Sorry, I lost my train of thought in the notes. Okay. So even that series, that triboelectric series, is not really the most reliable. And among scientists, there's not really a strong consensus on like, okay, this is how these things happen. So if you just do like a very cursory look of like, okay, how come when I rub a balloon on my hair, it stands up? It's like, oh, well, your balloon is going to pick up charge from the, from that interaction. And so it'll be negatively charged. Your hair will be positively charged. And that's why it stands up. But it's like, is it the electrons moving? We don't know for sure. And there's a lot of reasons it's hard to tell. One is like in everyday life scenarios, there's lots of variables to control. Another is it's not a process in equilibrium. So it never gets to a point where you're like, okay, now this is steady and we can sort of study it. And then the third is a lot of important things are happening on a lot of different scales, like in terms of both time and size.
Okay.
So all those things make it hard to say like, okay, we're going to isolate this thing and find out exactly what's happening.
Okay.
So the short answer is, who knows?
What the heck? That's so interesting. It seems like one of those things that is so everyday that it would be like, oh yeah, we know.
Yeah.
But it's weird when there's a mystery or something is like at least a lot more mysterious than we'd think.
Well, there are kind of two of the most interesting, I thought, and relevant pieces of research that have come out like since 2019. So literally in the last 5 years.
Wow. Since this podcast has existed.
I know.
We started that year.
Yes. Okay. So somebody early on, I meant to say this at the beginning, asked about static electricity. And I remember being like, there's not much good information on this. And sometimes I'll go and look it up. And if I can't find good sources or if I don't feel confident or if it doesn't seem interesting, I'm like, nah. And I remember feeling that way. So then when I looked it up this time, I was like, well, there's way more information, but it's all since 2019. And some of it even since 2020, it was like a 2024 publication. So
that's crazy.
A lot of recent publications on this.
Yeah.
But so one thing that they found is when you repeatedly use the same materials over and over, you could start to consistently predict more and more what was going to happen. And that is because the physical act of them coming together and interacting with one another was changing the shape of the surface of the material. So this is one of the things that I mean when I say things are happening on like several different levels. Like something can look flat to our macroscopic eye.
Okay.
But then on the microscopic level, so they're thinking of sort of like macroscopic scale, microscopic scale, and then nanoscale is like at the particles. So on the macroscopic level, the balloon surface looks flat, right?
Yeah.
And then you rub it against something, and if you zoom in on a microscope, you'd actually be able to see like balloons or other things have like a little bit of a rough edge to them. And when you're rubbing them together, even if you can barely detect it, you're going to get small like malformations, little deformities. It's going to change the surface and maybe even smooth it out.
Right.
And so that will make it less likely, potentially, less opportunities for it to interact and gain charge. So at this microscopic scale, changes to the surface of a material are directly related to their tendency to pick up static shock. So that's one thing.
Yeah.
And another thing is they're trying to study like, okay, friction obviously matters. Like rolling, the friction you get from rolling something is different than the friction you get from like rubbing something or just like touching, right? So they're doing some research on that. And this is where we get to at the micro scale. If you're rubbing two things together, they're creating friction, and friction happens because we have two things that are sort of resisting moving.
Mm-hmm.
And so that like resistance in moving is going to physically cause changes to happen, both on the surface, but also in the distribution of charge. So probably electrons moving on the surface of the molecule, or the surface of the material.
Mm-hmm.
So one side of the surface could be physically experiencing something different than another based on like the charge distributing through the repulsion with the other material.
Okay.
And so that can cause charge to maybe accumulate in one area versus another.
Okay. Yeah, I was starting to like right before you said that, my mind was starting to go toward like, why is it that all these things have like a friction vibe to them? And then immediately you said that, but I'm like, it is weird that like even though it's very different materials and stuff, right? Like balloons or coffee or astroturf or something like that. It's like, or carpet, right? You know, it's like just so interesting that these things are so different. Materials are so different from each other.
Yes.
And yet this is present in all those different areas.
Well, and one thing said that insulators are going to be able to do it more, but then it was hard for me to find a specific definition of like, okay, when you're saying insulator, what do you mean? Because I think when I think of that, that's something different than, you know, so that I didn't get good clarity on, but it is weird that it could happen in all these different things. And so you want to be, it's natural for us to want to then classify like this material is going to do it more than this material or whatever. And we see that naturally happen. Like some things pick up static way more than others, like in the dryer or whatever. So why? Why do some materials do that more than others? So the material does play a role, but there's also at a deeper level something else going on where even one material is not going to act exactly, even the same piece of material is not going to act exactly the same way every single time because its interactions at the surface level on the microscopic level, they're going to be changing the surface of that material.
Wow.
I know. Isn't that interesting?
Yeah.
But it's not very satisfying.
Right.
But it's just like a work in progress. Right now, we know, though we don't know very much, but these are two sort of breaking news items where there's evidence where they're able to like calculate, okay, like this is how friction is impacting it. And we've been able to calculate and get consistent results of like, oh, this is how we're anticipating this charge moving. And then on the other side, we have the surface material. So it's not really a traditional chemistry lesson. It's just more of a, we don't know as much as we think we know. And that's interesting.
Yeah, that is. And it is in some things we've talked about where there's less information about it, or as soon as we begin the lesson, I realize, oh, right, it's way more complicated than everything else.
Yeah.
Mosquito stuff is a great example of that, right? It's like, for the average person, we kind of think like, why won't they just get this figured out, you know?
Yeah.
And then as soon as you listen to one of the episodes, it's like, oh, right, we don't fully know which things attract them more than others or whatever. But we're beginning to understand. In this case, what's surprising to me about it is it, even from the outside, seems simpler in many ways than mosquitoes.
Yeah.
Because it's not like you're dealing with a whole other organism that has its own programming.
It's just materials. Yeah.
Just materials interacting in a way that's kind of these like basic intermolecular stuff, like we talked about, which is on one hand basic, on the other hand, like crazy and fascinating, and does create crazy weird stuff like geckos sticking to walls.
I know.
And stuff. So yeah, this is interesting.
I do remember feeling the same way when I looked it up before, being like, there's not good material on this, and why? Like, shouldn't they have figured it out? And there was one of the things that I've linked to is like a reflection piece that got published in a peer-reviewed journal. And they talked about like, here are the reasons why this is this is actually difficult to nail down. It's like, there's a lot of things happening at a lot of different scales, and it's never going to be like, with like most chemical reactions, they get to this equilibrium where you're like, okay, this side is favored or this side is favored. And, this is going to happen in a way that, okay, we can kind of get the system to stay still a little bit so we can study it. But it's harder to do that here. But you can like test the charge on surfaces of things and see if they repel something or, there's a really cool video from the American Chemical Society. They have their YouTube channel Reactions where they like will do little mini experiments and explain phenomenon. And he did like a whole thing where had balloons and, tested out like, okay, what is really happening here? And he got one area on a balloon to be negatively charged and the other area of a balloon to be positively charged. And he tested it with like, he just attracted it to something else, but like one side repelled, I think it was a piece of tape. And then another side drew it closer. And so like within one balloon. So that was really interesting.
What the heck?
And he also tested it like before they've been blown up, they were neutral. But then when you blew them up, then they like the surface of the balloon started to have a negative charge from what? Just the particles of air interacting with it,
Yeah.
So there's a lot that we don't know about this. And so, but you can for sure say that there will be a buildup in charge in one place or another, and that will cause the static like repulsion or static cling. And then the static shock is much like we talked about in the lightning episode, sort of like the distribution back.
Yes.
Like the charges are putting themselves back right.
Right.
So it's sort of like, oh, you have a bunch of electrons here. There's not enough electrons here. We're going to come close together. And as soon as they can find a way to travel a pathway, they'll do it.
Right.
So you can know that that's what's happening with static shock and with static cling is something has extra electrons or not enough electrons. And so they're going to be drawn to one another based on the charge.
Okay.
So like at the very simple level, we know that's what's happening. But then on the going deeper, it's like we don't know why it's happening. We have some ideas and we're knowing now some things are for sure coming into play.
Yeah.
But not to the point where we can consistently say like this is always going to be more likely to pick up a static shock than this, or this is for sure the mechanism that we're using to transfer this charge.
Yeah. Like it seems like in other areas that we talked about, like batteries and stuff, like trying to make something where or like in the case of like lightning or whatever, it's like something where you have intentionally created an imbalance.
Yeah.
It's like it takes a lot of work and it's like you'd have to, just kind of know what you're doing. Right. Yeah. But in the case of the static stuff, it's weird that it's happening when like, why would a balloon rub against someone's hair make a lot of electrons go to one versus the other? It just doesn't really, it's like, why
is that happening?
Yeah.
But it does. You
like,
can tell something's happening that then the hair is attracted to the balloons, than it wasn't before.
It's like in other ways, it's like nature doesn't want this to happen as much as it can, right? So it's like, why is this happening here when this isn't really supposed to happen? Yeah. And a lot of these...
You can think of like when you're putting friction and rubbing things together, you are putting energy into it. And energy is behind like reactions happening. It's like energy needs to happen for these molecules to be able to get close enough to interact and whatever. So that kind of makes sense to me of like the rubbing also playing a role in like, okay, we're putting in mechanical energy, Right. So that kind of makes sense.
Yeah.
But then it still is weird that it's hard to consistently track it,
Yeah. Huh.
So... but you're right. We have talked before about water dispersing it because we talked about, what episode was that on? Was this on the episode for dryer sheets? That if you use dryer balls or whatever, static can be a problem. And whenever I have that, I'll just mist water and it seems to solve the problem.
Yeah. What's weird about that is that's one of those things that before we ever talked about this kind of stuff and I had heard about spraying water for coffee beans, taking a static away. For some reason, that just like intuitively makes sense in a way that I cannot explain. I'm like, this water would do that, but why would it? Like, but it just feels right.
Yeah. Well, I think water has a lot of stuff in it that can conduct electricity, right? Like a lot. It has like salts and things like that would allow it to disperse whatever charge is present.
Yeah.
So I think that's why. But
Right.
yeah, why does it feel right? That's interesting.
When I can't really describe that. Like I couldn't even got to that, right?
Yeah.
I just think like I definitely know water can conduct stuff because you can like you don't want to be in a pool when it's lightning.
Yeah.
But and I guess the other thing is like, oh, these very dry particles.
Yeah.
Like you said, the grain thing. Like that seems like this is a environment static loves.
Mm-hmm.
So as soon as it's like wet, seems like it wouldn't. But
well,
like
and
why?
that is why static electricity and static shocks are more likely in winter, is because there's less water in the air, which we've talked about that before. Colder air holds less water. And so if there's less things to disperse the charge, then the charge is going to be stuck on you until you can find the thing that will let it spark. So
interesting.
Yeah.
Wow.
Yeah, water is like the antidote.
Mm-hmm. It's weird that whenever that I remember as a kid in the winter, my hair being more staticky.
Mm-hmm.
And one of the things was like, oh, use a dryer sheet on your hair.
Yep.
And I hadn't thought about that in a long time until now.
Yeah.
But also that hasn't happened to my hair now. I think there's,
Maybe you're more hydrated. Maybe you.
Oh, I don't use shampoo, like traditional shampoo. So maybe my hair is not getting like as dried out.
As completely dry. Yeah.
Yeah. It's like retaining its oils and stuff better.
Yeah.
Huh.
Yeah, I do feel like the quintessential kid with like crazy hair.
Yeah.
You know?
Like,
do they just rub their head on their pillow all night?
I remember like putting on my hoodie, like my pullover hoodie before like going to school. And then I do that and then my hair would just be like standing up, or it'd be like clinging to my head really badly, where it's like you can feel something's wrong.
Yeah.
It feels staticky.
Yeah.
And it's like, why is it doing this? It's like not behaving the right way.
Yeah.
And then if you like take a dryer sheet, rub it on your head.
That I'll give you my category on this. I guess I've given a few already, but right now the way static electricity is driving me nuts or static cling is I have these jumpsuits that I got. They're like athletic-y material. And they're so great. I got them all on sale or at like thrift stores, I'm like, oh, they're so comfy. They're all made of they're all athletic material, but not exactly the same. Like the black one feels slightly different than the green one and the blue one. I have it in 3 colors. I got them on sale. Okay.
Nice.
Great. If you like something, you get it in every color, especially when it's on sale. And then you could just have a uniform.
Yep.
I
have these. I mean, I don't think that's weird. You're like saying it in like a
defensive way.
Yeah.
I'm like, hey, they were on sale.
I have this pair of pants in 3 colors.
It's great.
Like, yeah, I'm just going to do that.
Yeah. If you know you like them.
Yeah.
But for some reason, the green and blue ones stick to my shins. And the black one does not ever. And to fix it, I will then take it off and put lotion or like spray water on my legs and then put it back on and it solves it. And I'm like, or I'll like turn the pants inside out and spray water on that. But I'm like and I hate the feeling of it, the way it clings to my shins. I'm like, now I don't, and it'll be like fine. And then I'll sit on my bed and like then stand up and then it's there. And I'm like, no.
Yeah.
So.
Yeah. It's weird how some material really is way more staticky than others.
Yeah.
Like we had this quilt we were using for a long time and it kind of fell apart. So we don't use it. We don't have it anymore. We have a different comforter on our bed. The one we have now, when I like lift it up to get in or like we're making the bed, it has some staticky pops to it, but our quilt didn't.
Yeah.
It just never did.
Yeah.
It didn't matter. It never did.
That is so weird.
Something about the materials just got to be different. Yeah.
Well, that's our episode for today. I know it was a little bit of a different one, but I thought it was fun to talk about some of the I love talking about what we don't know.
Yeah.
It's like, well, here's the simple answer. And I do feel like we teach it sort of like, I feel this way about photosynthesis too. It's like we teach it like we know, but we don't really know as much as we pretend like we know.
Right. Yeah.
So it's like we teach kids like, okay, and that's why your hair is standing up when you rub it on the balloon. And you're like, yeah, kinda, but we don't really know why.
And it's funny how like to a certain age of kid, that's a certain type of kid, that's plenty. But there's like the inquisitive kids that are like, but why though still?
Yeah.
That
was me.
And because it doesn't really make sense.
Yeah.
It's like you just can go one layer deeper and there's still more questions.
Yeah. I asked my students a quiz question today and it was like, this thing isn't what you would expect. Explain why. And I was like, well, the reason why is this, but that's not enough of an explanation because you need to know why it does that. It's like, really, you get partial credit for this, but that's not the whole story.
Mm-hmm.
And then they were like, you could tell they were like, and I was like, well, just think about if you said that to me in class, what would I ask you? What would the next question out of my mouth be? I was like, I would say why. And they all laughed because it's like, that is exactly what I do to them.
Yeah.
As I'm always making them think like, but why do you think that happens?
Yeah.
But why do you think that happens? And why that? So I do that because that's what I also do to myself and probably my mom.
Mm-hmm.
Poor mom. She's probably always dealing with that. Is always asking why. Actually, at her memorial, one of my friends mentioned like that she was so patient with that and would always respond to as many of the questions as I would give.
Nice.
So it's very sweet.
Yeah.
All right. Well, should we wrap it up there? Do you have any more static stories you want to tell?
I think I told them all. I didn't even think about trying to stay them for some of the category stuff, but just was happening. We were talking, it was just firing. I was realizing. I think that's kind of it. That quilt one's the last one I got, I think.
Okay.
Mine
is also the blanket when we're camping blankets. We have those like, they call them, I don't know. Some people call them puffy blankets. So they almost feel like windbreaker material.
Oh, yeah.
We have those. And then we have like some cozy blankets.
Nice.
So.
Nice.
All right.
Well, thank you for teaching us about that.
Yeah.
And in a way, teaching in another way, also shining a spotlight on a mystery.
Yeah.
And,
well, I think that's always fun,
Oh, for sure. So if you have a question or a thought or an idea for an episode or follow up to this one or a mystery that you're experiencing in everyday life that you think might be chemistry, please let us know. Reach out to us on our website at chem4yourlife.com and you can submit thoughts, ideas, questions there. We'd love to hear them. So many of our best ideas come from y'all. So don't hesitate. If you'd like to help us keep our show going and contribute to cover the costs of making it, you can join our super cool Chem community of patrons on patreon.com/chem4yourlife. You get an ad-free feed of the show. You get a bonus episode every month just for you. You get some behind-the-scenes stuff. You get, I feel like I always forget. There's something I want to say here that I always forget one of them.
Ad-free episode, community.
Community. I said that one. Maybe I did say it all.
Maybe so.
And most importantly, you keep the show going, keep it free for everybody, which is awesome. And we try to do as much as we are able in our limited time and capacity just to say thank you. And we'd love to get to know our community folks over there. So we'd love to have you. Chem4yourlife.com. Patreon.com/chem4yourlife. But if you can't do that, you can also grab some merch over at chem4yourlife.com/store.
And then when people compliment it, you can say, thanks, it's from my favorite podcast.
Lots of stuff over there, including some stickers that are dope. So, if you're like, I've got plenty of t-shirts like all of us do. We all have too many. Totally get that. These are cool. And I like to get a new t-shirt and then get rid of some old ones. Great excuse to do that. And, some of them shrink, they get holes.
Yeah.
Or I just don't even really like it and I just never wear it.
Yeah.
So pass it on,
Yeah.
But that helps to keep the show going. And lastly, and still very importantly, you can rate and write a review on Apple Podcasts or Spotify. You can subscribe to us on YouTube, leave a comment over there. Those things help us be found by others, help the chemistry of their everyday life be explained to them, and it helps a lot.
And just a special way to say thank you to every single one of our community members. Well, I forgot to say that this episode of Chemistry for Your Life was created by us.
Oh, yeah.
It was, though. And honestly, really, also, it was created by y'all, by our community who makes it happen. So we want to shout every single one of you out every single time. So we want to say thank you to Hunter, Chris and Claire, Stephen, Timothy, Katrina, Scott, Vince, Kyle, Brian, Latila, Rachel, Elizabeth, John, Jesse, Doreen, Chelsea, Heather, Ash, Emily, Avishai, Chelsea, Christina, Jacob, Venus, Suzanne, Erica, Cullen, Jeanette, Sierra, Autoclave, Julie, and Emily. And if you want to learn more about the episode's resources, you can check out our references linked in our show note or on our website, or in the description below the video, depending on where you're watching. And I think that's it. And I think I'd like to quote my shirt when I say, "Yay, chemistry!"
Yay, chemistry. And also, may the intermolecular forces be with you.
With you.
Mm-hmm. Amen.